I was sat at my desk, it was a very normal day until this signal appeared on my screen. I threw my hands up, I started shouting and running around the office. Very excited, was just not expecting to see it.
For decades, astronomers have been detecting flashes of gamma rays, high-energy radiation, coming from all over the sky using satellites orbiting the Earth. Their origins remained a mystery for 50 years, and at first they were even hypothesized to be the detonation of nuclear weapons in space. But we now know these are some of the most energetic events ever witnessed, visible halfway across the universe.
We know that these gamma ray bursts are so bright that they must be produced by some extremely violent cataclysmic event. The best guess anyone had for such an energetic process is the collision of two neutron stars.
A neutron star is the core of a dead star, but it produces something that only faintly glows in comparison. However, neutron stars are unbelievably dense. If you take one sugar cube-sized block of neutron star matter, that weighs as much as Mount Everest.
When two neutron stars orbit each other, they give off energy as gravitational waves. This causes the stars to gradually get closer together until they're orbiting each other hundreds of times per second, and eventually, they collide.
1:41 p.m. on August 17th, LIGO's Hanford detector recorded what could have been a gravitational wave signal. Moments later, we got an alert that the Fermi satellite had just detected a gamma ray burst.
When we realised we'd seen this signal in both gravitational wave detectors and gamma ray burst detectors, we just hit the roof. It felt like Christmas. We started telling astronomy partners where to look so they could point their telescopes.
Dozens of telescopes around the world immediately sprung into action, and within a few hours they saw the afterglow of the two neutron stars colliding near a galaxy just 130 million light years away, which is quite close for us.
This was the source of the gamma ray bursts. The 50-year mystery was solved.
In our wildest dreams, we never would have imagined that we would detect a gravitational wave source this close. It was 10 times closer than anything we've ever detected before. It's allowing us to extract a huge amount of information about neutron stars, which are the most extreme nuclear physics environments in the universe today. There are lots of theories out there about how matter behaves at the crazy densities inside neutron stars, and finally we're beginning to narrow down which of them might be correct.
These collisions are extremely important, even for us here on Earth. It is thought that all of the precious metals, including gold, silver, and platinum, were produced in collisions just like this one.
There's a huge amount of science we can do with these events. For example, because this was discovered in both gravitational waves and by other telescopes, we can even measure the expansion of the universe in a new way. And with all three advanced gravitational wave detectors in the process of being upgraded, there are sure to be many more to come. This is just the beginning.